Welcome to Dr. BT's Chemistry Essentials, A-Level Chemistry Made Easy. In this video we're going to start to look at how we quantify solutions using both volume and concentration. And then we're going to look at how we express concentration in two different units, moles per decimeter cubed and grams per decimeter cubed. So taking a look at this quite poor drawing of a solution, it contains two components, solute and solvent. So the solute is the actual substance that is dissolved in the solvent, and those two combined make our solution. Now we need to be able to quantify how much solute there is relative to how much solvent there is. This quantification is called the concentration. Alongside concentration, we also need to know the volume of the solution that we have. Before we turn our attention onto concentration, we know that volume, it can be expressed in two dimensions. It can either be centimeters cubed or it can be decimeters cubed. The link between these two dimensions is that 1 decimeters cubed is the equivalent to 1,000 centimeters cubed. This relationship leads to the first really important conversion in solution chemistry and also in gas volumes. If you want to go between centimeter cubed and decimeter cubed, to go from centimeter cubed to decimeter cubed, you need to divide whatever value you have in centimeter cubed by 1,000. If your quote is something decimeter cubed and you have to get into centimeter cubed, you're going to times this by 1,000. For example, if you had 800 centimeters cubed and you were to ask to give this in decimeter cubed, what you do is use this conversion, divide this number 800 by 1,000 to get you 0.8. And that is simply how you can convert between these two different volumes. And this will help when dealing with gas volumes also. Now we turn our attention to concentration. This is quite simply the amount of solute divided by the volume of the solvent. And there are two forms of concentration units. And it's all based on this quantity. Now quantity can either be amount, so moles, or it can be a mass, so grams per vol. In terms of volumes, decimeters cubed is the unit of choice. So we're going to convert these equations. And at A level, these are expressed as moldm-3 and gdm-3. Before we go any further, what I want to do is just explore the relationship between concentration and volume and how that links to the amount of a substance, the number of moles of it. And then that's going to allow us to understand why this is the best form for concentration. So if we look at moles, moles is otherwise designated as N in chemistry, and our dm cubed is the V for volume. And so if we know that concentration is N divided by V, rearrange this also equals N equals V times C, noting here that concentration, in order to equate to number of moles, has to be in moles per decimeter cubed. So we always need to have the units matching here. This leads to a really important equation, and one that you need to know. The reason this form of the equation is really important is because number of moles allows you to work across whatever physical state you have. Stoichiometry is the molar relationships within an equation. So if I have 2 moles of HCl reacting with 2 moles of sodium hydroxide, the relationships are 2 to 2. Or 1-to-1 ratio. But the only way we can compare that is by having the same unit, which is moles, but different physical states, solids, aqueous solutions, and gases, described by different quantities. So solid is mass, which is related to moles by taking the mass and divided by the molecular mass. Gases are described by their volume. They are a gas at standard temperature and pressure, then we can use volume in decimeter cubed divided by 24 decimeter cubed to get N, the number of moles. If our gas is actually not at standard temperature and pressure, we have to use the ideal gas law. That is just pressure times volume divided by the gas constant R times temperature in Kelvin. We've been discussing here, aqueous solutions have a concentration and a volume associated with them. As stated here, N equals V times C. So it's really clear that no matter what chemical substance that we are using, whether it be solid, aqueous or gas, as long as we can use those quantities in order to work out their number of moles, then we can compare the amounts of any substance to each other. I appreciate this is getting quite busy, but we're drawing lots of concepts from not just the idea of solutions, but across all of moles and dealing with different substances. But what we do need to just finish off is, if this is so important, moles per decimeter cubed, then if we're given a concentration grams per decimeter cubed, how do we jump from this unit into this unit? The key thing here is the only thing different is we've got grams and then we've got moles. Now, if you think about it, and if you want to pause the video here, what is grams? It's a mass. Moles is N. What equation do you know that links these two things together? Hopefully you've spotted that it's this equation here. We're giving a concentration grams per decimeter cubed. To make it useful, we need to get into moles per decimeter cubed. And that's going to be linked by this equation here. Now, if moles per decimeter cubed is basically N, to work this out, we need to take our concentration in the form of a mass, which is this here, grams per decimeter cubed, which fits in nicely. We've got mass here, we've got mass here. And just like this equation here, we need to divide this by the molecular mass of the solute. So the thing that has been dissolved in our solution. This is the third really important thing to take away from here of how to convert a concentration given in grams per decimeter cubed into the more useful form of concentration as moles per decimeter cubed. There's our three major things that we need to take away. N equals V times C, as long as that concentration's in moles per decimeter cubed. If it's not and it's given in grams per decimeter cubed, we need to use this conversion. And then any volumes you have need to be in decimeter cubed if you're going to input it into this equation, because again, all the units need to match. So for the first solution-based question to put some of these concepts into practice, I want you to pause the video now and see if you can work out the amount of sodium hydroxide using these quantities. Okay, so first of all, amount means N, okay, so number of moles. Even though we say the amount of a solid and we might be referring to mass, in chemistry we have to be really clear. Amount is moles, mass is for grams. So we're trying to work out N. We've been given a volume, but as you can see, the units of that are centimeters cubed. And we've also been given concentration of 0.1. And whilst we're only dealing with sodium hydroxide here, it's really worth noting that using brackets with each of these helps in more complicated questions. So what I've done there is extracted the information and labelled it up with the substance that it refers to. This is a really good habit to get into, especially as you get to more advanced calculations. Clear that we need to calculate N using volume times concentration, but remember the volume has to be in decimeter cubed and the concentration in moles per decimeter cubed. We can see we've got the correct units for concentration, so that's absolutely fine. What we haven't got is the correct units for volume. We've got it in centimeters cubed here. So if we've got centimeter cubes, we need to get into decimeter cubed. We've got to divide by 1,000. So 25 divided by 1,000 is the answer of 0.025 cubed. And so now we have the correct units to put into this calculation here. Simple multiplication is 0.0025 moles. At this point, I want to make really clear the strategy we used in order to approach this calculation. First was that we used the bug method. We boxed the value we were trying to calculate, and then we underlined any given values. Instead, we wrote the equation or equations that unites the values. So because we had C, V, and N, they were all united by one equation, N equals V times C. Sometimes you might have multiple formula triangles that you have to merge. The third step was to check the units and convert if necessary. We saw that volume was in centimeters cubed, so we converted it using this conversion here into decimeter cubed, so it fit the equation of choice. Then we rearrange the equations 2 if needed. in order to get the value that we want to calculate, the one boxed. You substitute in the values once it's rearranged. Obviously in this case it was already giving us number of moles, so we substitute in the values. Final step is just to put these values in a calculator and then check that the answer has the correct SI units. Okay, so what I want you to do is apply those same 6 steps to this question here. So first of all, remember, box the thing you're calculating and underline any given values, and then go from there. Pause the video here and have a go. Now, if you got the answer of 0.4 grams, then you've done the right thing. If not, or you're uncertain about if you were efficient enough and you're working out, then I'm just going to walk you through this. Well, what we've done is boxed the mass that we're trying to calculate, and then I'm going to underline any given values. It's the habit of really just identifying what substance is with it, because if you've got multiple substances, this is where the values can be a bit more tricky, so it's a good habit to get into. So I've underlined all the given values. Also at this stage, it's worth noting that if you're ever given the identity of the substance and therefore the formula, then you can also work out the MR because you've got access to a periodic table. The second step is to then write equations that link any of these terms together. You know that M and MR are linked together by N, number of moles. And remember, the mass is what we're trying to work out, so at this point here, this will be where we're kind of aiming towards. And then also we've got volume and concentration, and that is linked together by this formula here. My next step is just to check the units match the units of those particular formulae. So obviously mass is going to come out in grams. That's of no relevance because we're going to calculate that anyway. MR, well, MR is grams per mole just by nature. We've got concentration, that's in moles per decimeter cubed, but that does not match the centimeters cubed here. So in terms of units, we need to change the 50 centimeter cubed into decimeter cubed in order for this to fall into this equation. That we divide by 1,000 and gives us 0.05 decimeters cubed. We're happy with the units and the values that we're given. Now, step 4 requires you to rearrange any equations that you're given. So we've got these 2 equations here. We want to get mass as our term. Take the molecular mass over, it's N times MR. Now we don't have N, so we're going to have to use the volume that's given and the concentration that's given here. You could do this in one step, so work out the number of moles and then substitute this in later. Or what I'm going to do is basically combine the 2 equations. In this case, mass equals volume times concentration, as that is just what N is for this part here, times the molecular mass. Say if you don't want to combine equations because they're a bit confusing, you can do it by step-by-step part. Now all that remains is to substitute in the values that we've been given and also those that we've changed the units for. Volume is the 0.05. Our concentration is the 0.2 that we're given here. And our MR we can work out through the MR of sodium hydroxide, which overall is 40. All that now remains is we calculate and check the units of our answer. And we've got 0.4 grams. Now, in the units is usually most important when the answer line already has the units that it wants to be in. Obviously, this was an open answer, so whatever units you came up with. That's the 6 steps complete. Okay, the final question to finish on. What I want you to do is pause here, use the same approach to calculate the number of moles of hydrochloric acid in a 25 centimeter cube volume of a 7.3 grams per decimeter cube solution. Okay, if the number of moles answer you got was 0.005 moles, then you've got the correct answer. Take you through the process of this. We've boxed the one that we need to calculate and underline any given value. Equation, we've got N, V, and C, so this is the equation. Then we need to check the units of the given values. Well, 2 issues here. We've got centimeter cubed and we need it in decimeter cubed. And here we've got 7.3 grams per decimeter cubed and we need it in moles per decimeter cubed. So we're going to have to change the units. So volume first. Then let's have a look at our concentration. to use this relationship here. So we've got to take that 7.3 grams and divide it by the molecular mass of the solute. In this case, it's HCl. The answer of 0.2 moles per decimeter cubed. To be looking at rearranging the equation. Our equation is given in the right arrangement at the moment, so we've got number of moles. We just need to substitute in our values. Happy that we've got that. And then finally, put this into a calculator and check the units. That those units match those on the answer line. So you can see that this method is going to really help you when dealing with calculation type questions. Okay, so that concludes our first video on quantifying solutions using concentration and volume. And we've been looking at the equation N equals V times C and looking at the different forms of concentration. In the following videos, we're going to be looking at dilutions and how to deal with those, and also how to deal with questions around stock solutions. If you found this video useful, ensure that you like it and then ensure that you subscribe to the channel for new videos as and when they're uploaded.